In this video, we'll go through exam questions that cover the criteria, represent discrete data in tables, diagrams, and charts, including pie charts, bar charts, and line graphs. You can locate the questions on the mathsmath.com website under Level 1. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. Denise sells candles for 2 weeks. She wants to compare the number and type of candles she sold in week 1 with the number and type of candles she sold in week 2. After the second week of selling candles, Denise wants to produce a pie chart to compare sales of candles from week 1 and week 2. This is the pie chart for candles she sold in week 1. And we're given the different types: vanilla, lavender, cherry, and linen. This table shows the number and type of candles sold in week 2. We've got vanilla 80, lavender 120, cherry 100, linen 60. Draw and label the pie chart below for week 2. Let's see how many candles were sold in total in week 2. So 80 and 120, that makes 200. And another 100, that makes 300. And 60, that makes 360. So 360 candles, and also in a circle there are 360 degrees. So that tells us that we've got to give vanilla 80 degrees, lavender 120 degrees, cherry 100 degrees, and linen 60 degrees. All the information that we have so far would be enough for us to use a protractor, measure the angles, and do the pie chart. However, we've got some divisions given to us as well, which might give us some extra help. So how many of them are there in total? Let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So 36 divisions representing 360 degrees. So one division is equal to 10 degrees. So one of these means 10 degrees. Let's start by representing the vanilla candles. So 80 degrees. So we're looking for 8 divisions. We're going to start with this point. So always start with north, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8. I'll label this as vanilla. Now we'll do lavender, 120 degrees. So that is 12 divisions. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cherry, that is 100 degrees, so that will be 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And finally, we have linen, so that is 60 degrees. We should have 6 divisions for this, so let's double check. We have 1, 2, 3, 4, 5, 6. So that is correct. Now you can color these in, whatever colors you want to give them. Just make sure you include the colors here in the key. So if you color in the vanilla sector in red, you do this in red. in my case I haven't colored them in, so I'm going to take it off. Make one comparison between week 1 and week 2. Well, the first thing I can notice is the vanilla sector. It represents a quarter of the whole thing, of all the sales. So that is more than what we have for week 2 for vanilla. As you can see, this is less than a quarter. So we can say that more vanilla candles were sold in week 1 than in week 2. My comparison referred to the vanilla candles, but you could do it on any of the other types that are here, like lavender, cherry or linen. You are reviewing the nursery's expenses. You create this spreadsheet. How much does the nursery spend each week? Write the answer in the box below. So we're going to add the amounts for gas and electricity, food and activity materials. So £75.13, £62.95, £41.92. So 3 and 5 is 8, and the 2 is 10, 0 down, 1 carried over, 1 and 9 is 10, 1 and 9 is 10, so that is 20, 0 down, 2 carried over, 2 and 5 is 7, and the 2 is 9, and the 1 is 10, so 0 down, 1 carried over, 6 and 4 is 10, and the 7 17, and the 1 is 18. So £180. Represent the expenses data from 2A in a pie chart. Draw the angles to the nearest whole degree. Show your working out in the box below. So all the expenses that we've just worked out, we need to represent them in the pie chart. Good thing is that the total is £180. So we're going to represent the total in 360 degrees. What does this tell us? That £1 will be represented by 2 degrees. So double. Taking them in turn, we've got £75.13 for gas and electricity. I'm going to round this to £75. And I'm going to round £62.95 for food to £63. And the £41.92, I'm going to round that to £42. And to work out the number of degrees that we're going to represent gas and electricity by in the pie chart, we're just going to double the 75. So 75 and 75, that gives us 150 degrees. For food, 63 and 63. So that gives us 126 degrees. And finally, for activity materials, I'm going to do 42 and 42. which is 84 degrees. We'll start with gas and electricity, but you could start with any of them three. Aligning the protractor. It's important that you start with the north, and it's very helpful that we've got the line already. So we'll start with gas and electricity, go from 0 to 150. I'll make a mark here. Now we'll measure 126 degrees for food. And we'll double check that we've got about 84 degrees for activity materials. That is 80 in fact, so what we're going to do is we're going to give these other two sectors about 2 degrees less, so somewhere here and somewhere here. Now I'll use a ruler to connect the 2 points with the center of the circle. And I'll label the sectors, so gas and electricity, food, and activity materials. We are preparing a presentation on the different types of birds in the reserve. You display the figures in a chart. 1/5 of birds are woodpeckers, 70% of the birds are owls, the remainder of the birds are turtle doves. Calculate the angles to complete the table below. The diagram is not to scale, so that tells us that we shouldn't try to measure the angles ourselves. We need to work this out. So we know that there are 360 degrees in a full circle, so there will be 360 degrees here as well. So we know that 1/5 of the birds are woodpeckers, so we're going to work out 1/5 of 360. 1/5, that is 1 out of 5, so you can imagine the circle being split into 5 equal parts. So we're going to work it out by doing 360 divided by 5. So how many 5s fit into 36? That is 7, because 5 times 7 is 35, and we have 1 remaining. Now how many 5s into 10? That is exactly 2. So the answer is 72 degrees. Now we know that 70% of the birds are owls, so what we're going to do is work out 70% of 360. As we can't use a calculator, we'll use a 10% method. So 10% of 360, that is 36, because 360 divided by 10 gives us 36. So what we can do is 36 times 7. So 36 times 7. 7 times 6 is 42. 2 down, 4 carried over. 3 times 7 is 21. And the 4 is 25. So 252 degrees. And finally, the remainder of the birds are turtle doves. So what we're going to do is add 72 and 252. So 4, 12, 2 down, 1 carried over. So that is 324 degrees we have already. We're going to take it away from 360. So we need to take away 4 from the 0, which means we've got to borrow 1 from the 6. This becomes 10. Take away 4 gives us 6. 5 take away 2 gives us 3. 3 take away 3 is 0. So this is 36 degrees. The company you work for records the number and type of packages it delivers. Each month the figures are displayed in a chart. The angles on the chart represent the number of parcels delivered. Small parcels make up 2/5 of the packages. Letters make up 17% of the packages. Large parcels make up the remainder of the packages. Complete the table below. Again, diagram is not to scale, so there is no point in measuring the angles. So small parcels make up 2/5 of the packages. So we're looking for 2/5 of 360 to find the angle in the pie chart that represents small parcels. So we're looking for 2/5 of 360. So we need to first work out 1/5 of 360 and then double that. So 360 divided by 5. How many 5s fit into 36? That is 7, because 7 times 5 is 35, and we have 1 remaining. How many 5s into 10? That is exactly 2. So 72, that is 1/5. 2/5 will be 72 and 72. So 2 and 2 is 4, 7 and 7 is 14. So 144 degrees for small parcels. Now we've got letters that make up 17% of the packages, and that will be 17% of the circle. So we're working out 17% of 360. Again, we can't use a calculator, so we'll use the 10% and the 1% methods. So 10% of 360, that is 36. 5% of 360, that is half of the 10% amount, so half of 36 is 18. So we have 10%, we have 5%, so that makes 15. Now we need 2%, so we'll do 1 and 1. 36, 18, 1%. That is 1/10 of the 10% amount. So 1/10 of the 36, which is 3.6. But also it's 1% of 360, so you can do 360 divided by 100. So that's moving the decimal point 2 places to the left, so we get 3.6. So now we have 17% in total, and we can add the numbers here. We need to make sure we line them up correctly before we start adding. So we've got units under the units, and tenths under the tenths, and tenths under the tenths. If it helps, you can add 0.0 for both of these two whole numbers. So 6 and 6 is 12. So 2 down, 1 carried over. 6 and 8 is 14. And 3, that is 17, and 3 is 20, and the one we carried over, that is 21. So 1 down, 2 carried over. 3 and 2 is 5, and the 1 is 6. So 17% is equal to 61.2 degrees. And we've got large parcels as well, so that's the remainder. So we're going to add 144 and 61.2, 5, this is 10, so 205.2. We're going to take it away from 360. So we're taking away 2 from 0, which means we've got to borrow. We can't borrow from the units though, because there are none, it's 0. So we're going to borrow 1 from the tens. So this becomes 5 and this becomes 10. Now we can borrow from the units because there are 10 of them in there. So it becomes 9 and this becomes 10. 10 take away 2 gives us 8. 9 take away 5 gives us 4. 5 take away 0 gives us 5. 3 take away 2 gives us 1. So large parcels will be represented by 154.8 degrees. Jake draws a pie chart to show how he'll spend his income. Jake spends £420 on household bills. How much more does he spend on clothes than on leisure? So we can see that household bills are represented by 140 degrees in the full circle. So 140 degrees is equal to £420 because degrees go in proportion with the amounts, just like anything else that we've worked out so far with the pie charts. So we can simplify this further now to work out how many degrees per each pound or how many pounds per each degree. Either way, it should be absolutely fine. Simplifying both numbers by dividing them by 10, I'll get 14 degrees equals 42 pounds. I can now divide both numbers by 2. So I get 7 degrees equals 21 pounds. I can divide both numbers by 7. And I get 1 degree is equal to 3 pounds. Now, to answer the question, how much more does he spend on clothes than on leisure? So clothes, that's represented by 90 degrees. So that means one times 90 gives us 90. 3 times 90, that is 270. So you multiply 3 by 9, which gives us 27, and then you just add the 0. So that is 270 degrees for clothes. Leisure, that is 70 degrees. So 1 times 70 gives us 70. 3 times 70 is 210. So to work out how much more he spends on clothes than on leisure, we'll do 270, take away 210, which gives us £60. We're now moving to the calculator questions. Jimmy works in a shop. he has this information about the 72 items sold last week. Jimmy starts to display this information in a pie chart. Complete the pie chart for Jimmy. In order to complete the pie chart, we need to work out how many degrees we'll give to the phone and the laptop. So we're looking for the angle size, in other words. So for the tablet, we've been given the number of tablets sold and the angle size. So we have a ratio of 15 to 75. We're going to simplify, so we are then working out for each one sold what are we representing by in terms of degrees. So 15 to 75, we can divide both numbers by 5. So 15 divided by 5, we get 3. 75 divided by 5 is 15. Now we can divide both numbers by 3. So it's 1 to 5 the ratio. So one item sold is represented by 5 degrees. So what we're going to do is multiply 44 by 5 and 13 by 5 to work out the respective angles within the pie chart. So that is 220 for the phones, and for laptops that will be 13 times 5, which is 65. So we'll use the protractor . So from the end for the tablet, I'm going to go to 220 degrees for the phone. Now we'll measure the angle representing laptops just to make sure we've done everything correctly. So it should be 65 degrees. And that shows we've done this correctly. The table gives some information about the number of visits to a gym last month. Complete the frequency column. On the grid, draw a suitable graph for this information. So we have number of visits 1 to 5, that is 5, 10. 6 to 10, we have 5, 10, 15, 20, 25, 30, 35, 40, 41, 42, 43. 11 to 15, we have 5, 10, 15, 20, 21, 22. More than 15, we have 5, 10, 11. So we'll say number of visits (1 to 5), 6 to 10, 11 to 15, more than 15. or we can use the more than symbol. That would be better. And vertically, got frequency, the highest is 43, so 5, 10, 15, 20, 25, 30, 35, 40, 45 works. So we've got 10 for 1 to 5, for 6 to 10 we have 43, the frequency, so I'm going to go up to 43. You should use a ruler when you do this on paper. (11 to 15) we have 22, so there is 20, 21, 22. Greater than 15 we have 11, so there is 10, 11. Now you can colour the bars in or draw patterns on them, whatever you prefer, or leave them blank. Should all be fine, whichever way you prefer it. Kate has this information about the total monthly sales for a shop in 2018. Kate needs to put this information in a table. The table must show the total sales for each quarter of the year. So we have quarter 1, quarter 2, quarter 3, quarter 4. Again, you need to use a ruler when you do this on paper. Give the arrows the same width. So total number of sales and quarters. Quarter 1 covers January to March, so January 160, February 60, and March 150. So we're going to add all of these together. $370. Second quarter covers April to June. So for April we have 90, May 30, and June 10. Which is 130 in total. Quarter 3 covers July to September, so July 40, August 50 and September 140. So that is 230 in total. And the last quarter covers October to December. So that is 70 and 90 and 140. So 300 in total. And that's the table complete. John is a milkman. The table shows information about the types of milk John delivers each day. Draw a pie chart to show this information. Remember to label the chart. So we're given the type of milk, skimmed, semi-skimmed and whole. We've got number of deliveries for each of them and the angle in the pie chart. So 60 degrees for the skimmed milk, 165 degrees for semi-skimmed, 135 degrees for the whole. We start with 60 degrees for skimmed milk. $165 for semi-skimmed, and whole milk should be 135. So something around that. We're going to give this just 1 degree less, and this one as well. Graham is the manager of a fast food restaurant. The table shows the amount of money lost due to food waste for 5 days. Graham wants to draw a graph to show the amount of money lost due to food waste. Draw a suitable graph for Graham. Since the question doesn't specify, we could draw a bar chart or a line graph in this case. Since we're tracking the amount of money that is wasted over a period of time, from Monday to Friday in this case, a line graph also works. And that's what I'm going to do. I'm going to draw a line graph. So we've got the amount of money, and we've got the days from Monday to Friday. Vertically we'll show the amount of money, and the highest is £400. So starting with 0, we'll do 100, 200, 300, 400, 500. So that's the amount of money wasted in pounds. For Monday, we've got £190. So that's 150, 60, 70, 80, 90. Tuesday, 250. So 250. Wednesday, 210. Thursday, 345. Friday, 400. We'll connect the dots. And there we have the line graph. Every year, local authorities in England estimate how many people are sleeping rough in their area. The estimates for England over the last few years are shown in this table. The data is represented in this line graph. The axes are incomplete. Complete the line graph. Okay, so it's a line graph, so that means horizontally we're going to show time. So that will be year from 2011 to 2016. Vertically, we'll show estimated number of people sleeping rough in England. So this will be estimated number of people. And we've got them going up to 4,134. So 1,000, 2,000, 3,000, 4,000, 5,000, and let's check. So the first one for 2011, that is about 2,100, 200, and that is correct. Let's check another point, maybe for year 2016. So it's over 4,000, 4,100, so between 4,100 and 4,200, and that is correct. So we've done this correctly. A company group raises money to help people who sleep rough. Volunteers pack shopping bags at a local supermarket and ask shoppers for donations. The table shows the number of volunteers who packed bags on 32 Saturdays in 1 year. Use the data to complete this frequency table. So, number of volunteers 0, frequency 1. Number of volunteers 1, frequency is 4, because we've got 1, 2, 3, 4 of them. Number of volunteers is 2, so what's the frequency? We've got 1, 2, 3, 4, 5, 6, so that's 6 of them. Number of volunteers 3, we have 1, 2, 3, 4, 5 of them. Number of volunteers is 4, so we have 1, 2, 3, 4, 5, 6, 7, 8. Number of volunteers is 5. Let's check, do we have 7 of them? So 1, 2, 3, 4, 5, 6, 7. And number of volunteers 6. We should have just one of them. We've crossed out everything in here, so that shows we've done this correctly. And we've got the total as well, which is 32. Do we have 32 numbers here? 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, so that is 32 in total. And if we add these numbers, the frequencies, the total should be 32. Joy draws this bar chart to represent the data for last year. Give 2 reasons why this bar chart is inaccurate. Okay, so looking at the scale, we're going 0, 10, 20, should be 30% here. So scale has a mistake. Should be 30%, not 25%. Also, it says percentage of total visits made to each web page last year. So finance has 50%, well-being 10, so that is 60 so far. And the 30, that is 90. Academic is about 5%, so it doesn't total 100%. So at least one bar is plotted incorrectly as the total for all bars is not 100%. Now I've got to say that not all bars in all bar charts should total a certain number, but because we're talking about total number of visits, they should add up to 100%. Summer looks at the weather forecast in Paris. The table shows a 7-day forecast. Draw a line graph to represent this data. So again, it's a line graph and time should go at the bottom, should be represented horizontally. So you're going to have day and then from Monday to Sunday shown here. It seems like it's been done already, which is quite helpful. Now vertically, we'll show forecast temperatures in degrees Celsius. So I'm going to say temperature in degrees Celsius, and it goes up to 23. So start with 0, 5, 10, 15, 20, 25, 30. That seems to work. So on Monday it goes up to 15. Tuesday and Wednesday 17. So 16, 17, 2 little squares represent 1 degree, because we have 10 little squares representing 5 degrees. So it's the same for Wednesday, 17 degrees. Thursday and Friday, 16. Saturday, 22. And Sunday, 23. We'll just connect these dots. And that's complete. Some scientists think that climate change might increase the number of earthquakes. Amina finds this information about the magnitude of some earthquakes. She needs to draw a bar chart. Draw a bar chart for Amina. So we've got different locations, and we'll show magnitude of earthquakes. And E goes up to 9.1. That's the highest. So starting with 0, we go to 2, 4, 6, 8, 10. So 8.0, or 8 for Peru. Fiji, that is 8.2. So one little square higher, because a little square represents 0.2. Ecuador, we've got 7.8. So 7 will be halfway between 6 and 8. So that is 7, 7.2, 0.4, 0.6, 0.8. Or one little square less than 8. Because 7.8 is like 8 take away 0.2. Russia 8.3. So there is 8, 8.2, 8.3. And Japan 9.1. So 8.4, 0.6, 0.8, 9, 9.1. You'd need to use a ruler here when you do this on paper, so you can draw straight lines. And if you look at the numbers, they are around 8. So that shows we've done this correctly. This table shows the number of orders a salesperson got in 6 months. Draw a line graph to show this information. Okay, so horizontally we'll show the months from January to June. got the number of orders, which go up to 200. So we could do 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220. So we've got January 150. That's right in the middle between 140 and 160. February 155. So that is halfway between 150 and 160. So somewhere here. March 170, halfway between 160 and 180. April 160. May 180. And June 200. Explain what your graph shows about the number of orders. The number of orders has gone up every month except for a dip in April. A school thinks their results are better than the national average. The school has a target for 65% of the students to achieve a grade 4 or higher in their maths GCSE. A school governor uses this school table to check results. She wants to compare her school's results with the national maths GCSE results for grade 4 and above. She sees these national results. She needs to write a report for the Board of Governors. She says that the school has met its target and that its results are better than the national average. Is the governor correct? Explain your decisions. Show calculations to support your explanation. So the target is for 65% of the students to achieve grade 4 or higher. And we've got the school's results here, so grade 4 and higher. So we have 7 and 11 and 18 and 22 and 27 and 55 students, so that is 140 of them. Out of the total, which is 140, add 27, add 22, add 11, which is 200. So 140 out of 200, that is 0.7 as a decimal, which as a percentage is 70%. So in terms of the target, the school has met its target. And that its results are better than the national average. Well, that's the bit that we need to check. So what is the national average? We've got that here in the pie chart. So we're interested in grade 4, 5, 6, 7, 8 and 9. So we'll add the respective percentages for all of them. So 22% plus 18% plus 12% plus 10% plus 7% plus 4%. So that is 73%. So what we're going to say, the target has been met, but they're not better than the national average. So we've said that the school's target has been met as 70% of all students got grade 4 and above. The results are not better than the national average, as 73% of students got grades 4 and above nationally. This chart shows the average monthly temperatures of Sydney and Dubai. What is the difference in the average monthly temperature of Sydney and Dubai in July? Difference means working out the difference by taking away the smallest from the largest. So it's July that we're interested in. There is July. So we've got 35 degrees and 10 degrees. So 35 take away 10 gives us 25 degrees. A parent wants a car seat for his child who is 36 months old. He needs a seat that is front-facing and uses a harness. He looks at this table. Which seat type should the parent buy? Explain your decision. So the child is 36 months old, which is 3 years. So we're interested in this row here. So we're looking for a front-facing car seat which uses a harness. So it needs to have both of these ticked. Front-facing and uses a harness. And within this row, toddler A, the seat type, doesn't have both of them ticked, but toddler B does. So I'm going to say toddler B, and the explanation is that it is for children 6 months to 4 years, 4 years old. Is front facing and uses harness. A salesperson must drive from Bristol to attend a meeting in Nottingham at 10 a.m. This table shows distances in miles between different places. He works out he needs to leave Bristol at 9 a.m. Is his calculation sensible? Explain your answer. So Bristol to Nottingham, that is 140 miles, and he leaves Bristol at 9 a.m. to arrive at 10 a.m, so within 1 hour. This is not sensible because he will need to do 140 miles an hour, which is outside of any speed limit, even on the motorway. So he would need to drive at 140 miles per hour, which is much higher than any speed limit, even on the motorway. A principal needs to report to the governors how absence rates have changed over the last 4 years. She needs to work out last year's percentage absence. What percentage of the total days were the students absent for last year? We're given the total absences in terms of days, which is 948 out of 39,500 that are possible. That is for all the students. So to work out the percentage, we'll do 948 divided by 39,500, which is 0.024. And as a percentage, that is 2.4%. It's like multiplying 0.024 by 100. She wants a chart for her report. She finds the following extra information. Draw a chart or graph for the principal's report. Okay, so we're going to say year and then label these as year 1, year 2, year 3 and year 4. We could do a bar chart or line graph. It doesn't specify here. I think we'll do a line graph because it shows the changes over time, but a bar chart is absolutely fine as well in this case. Need to keep the same gap between the years. So what is the highest percentage? That was 4 years ago, 6.8%. So starting with 0, we could do 1, 2, 3, 4, 5, 6.5. That's not enough. So we'll do 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for year 1, it goes up to 6.8%. Six 0.8 is here. Year 2, it goes to 5.6%. Year 3 goes to 3.2%. And year 4 is 2.4%. So there's been a decrease year on year. And we shouldn't forget to label the vertical axis, percentage of days absent, and that's complete. The table below shows the number of visitors to Highfield Castle last week. On Friday, there were 20% more visitors than there were on Thursday. Show your working out and then draw a chart on the graph paper to show the number of visitors during each day last week. We'll first need to find the number of visitors for Friday, so that is 20% more than on Thursday. On Thursday there were 150 visitors, so 20% of 150. So we'll do 20 out of 100 of 150. Which is 30. So we can add that on top of 150, which is 180. I'll show this in a graph. We can do a line graph or a bar chart. I'm going to go with a line graph. So horizontally, we'll show the days from Monday to Friday. Could have Monday here, Tuesday, Wednesday, Thursday, Friday. And then vertically, we'll show number of visitors, and the highest is 195. So from 0 to about 200. So it can be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 30, 40, 50, 60, 70, 80, 90, 200. So that works. So on Monday there were 165 visitors. On Tuesday, $195. So that is in between 190 and 200. Wednesday, 135. Thursday, 150, and Friday, 180. And that's complete. This is the 6th year that the show has taken place, so this question links to a previous one, but it doesn't really matter, and you can still answer the question. The table below shows the attendance figures at the show for the last 5 years. In Year 6, the attendance is 15% greater than Year 5. Show your working out and draw a chart to show the attendance for the 6 years. We'll start by working out the attendance for Year 6, and it's 15% greater than Year 5. For Year 5, that is 4,500, so we'll work out 15% of 4,500. 15%, that's 15 out of 100, of 4,500. So using a calculator, we'll do 15 divided by 100 times 4,500, which is 675. We'll add that on top of 4,500. Which is 5,175. We'll show this in the graph as well. So year 1, 2, 3, 4, 5, 6. I've put a 3 square gap between each of the years, but you could do 2, 1, whichever you prefer. I just wanted to space them out because that's better. It shows the progress or the change over time more clearly. And vertically will show attendance, and the highest number is the last one, so about 5,200. Let's see how many squares do we have in total. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and a bit. So 5,200 roughly. If we divide that by 22, gives us 236, so we're going to round it to 250 per each of these squares. So 250, this would be 500, then 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500, 5,000, 5,500. So we'll start plotting now. Year 1, 3,200. $3,200 will be between 3,000 and 3,500. But where exactly? Because we've got 20 little squares in here that represent 500 in terms of attendance. So what I'm going to do is 500 divided by 20, and that gives me 25. So each little square represents 25. So this is 3,000, 3,050, 3,100, 3,150, 3,200. Year 2, we've got 3,700. So 3,500, and we'll add 200 more. So that is 8 little squares. Year 3, 4,150. So 4,000 is here. Add in 4 more squares. We'll take this to 4,100. 2 more squares, 4,150. Year 4, 1,950, so 50 less than 2,000. So 2 little squares below 2,000. Year 5 has 4,500. And finally, for year 6, we've got 5,175. So there is 5,100, so that is 4 more squares, and 175, that is another 3. Now we'll connect all the points that we've plotted. And this is complete. Ben and Joe want to buy a house. An estate agent tells Ben and Joe about the houses in their area. 15% of the houses have 1 bedroom. 55% of the houses have 2 bedrooms. 30% of the houses have 3 or more bedrooms. The estate agent wants to display these figures in a chart to compare the proportion. Create a pie chart below to compare the proportion of houses with 1 bedroom, 2 bedrooms, and 3 or more bedrooms. Draw your chart and show any workings in the box below. So 1 bedroom, that is 15% of the total. So this will take 15% of the full circle. How many degrees is that? We'll work out 15% of 360 because there are 360 degrees in total. So 15% of 360, we do 15%, so that's 15 out of 100 of 360, which is 54 degrees. 2 bedrooms, that is 55%. So 55% of 360. So again, we do 55 divided by 100 times 360, which is 198 degrees, and 3 or more bedrooms, that is 30%, which is double the 15%. So we'll do 2 times 54, which is 108 degrees. Let's double check. Do these add up to 360? So 198 add 108 add 54 gives us 360. So we've done this correctly. Now we're ready to draw the pie chart. So we'll start with the 54 degrees for 1 bedroom. It looks like the circle is a bit out of shape because we've been playing with the images on screen, but when you do the real exam, whether on screen or on a piece of paper, that shouldn't be the case. So we're going to stop at 54. (198 degrees for 2 bedrooms). So 198 degrees, 1 less than what we have currently. and for 3 or more bedrooms it should be 108 degrees. Let's just double check. So it is something close to that. We're just going to compensate for the other sectors by taking away like 1 or 2 degrees. We'll label these now as 1 bedroom, 2 bedrooms or 3 bedrooms. The table below shows sales of laptops over a 6-month period. Draw a bar chart to show the sales of laptops over the 6-month period. So we'll show the months horizontally and the number of laptops vertically. There are 1, 2, 3, 4, 5, 6, 7, 8 squares, so I'll give them 1 each. There is no space for gaps in between. Number of laptops sold. Goes up to 172. So starting from 0, we could have 20, 40, 60, 80, 100, 120, 40, 60, 80, 5, and that's enough. So for January we've got 28. So there is 20, 22, 4, 6, 8. February 144. So 140. 244. So each little square represents 2 laptops. March has 82. So there is 80, then 82. April 126, 122, 24, 26. May 94, 90 to 94. June 172. So there is 170, that's 172. Rory works for a restaurant. One week, the restaurant runs a special offer from Wednesday to Saturday. The table shows the income from sales of drinks for the 4 days. On the grid below, draw a suitable chart showing the income from drinks. Again, in this case, we could do a line graph or a bar chart. Both of them will work. I'm going to do a line graph. So, horizontally, I'll show you the days from Wednesday to Saturday. Vertically, we'll show income from drinks, and it goes up to 1,400. So maybe 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. That doesn't work. So we'll go 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600, 1,800, 2,000. So Wednesday 800, Thursday 1,000, Friday 1,400, Saturday 700. So that's halfway between 600 and 800. And that's the line graph complete. The income from food comes from starters, mains and desserts. The pie chart represents the income from food during the special offer. In total, Rory wants 1/3 of the income from food to come from starters and desserts. Has this happened during the special offer? You must show your working. So, we're looking to find out if this angle here is equal to 1/3 of 360. So, what is 1/3 of 360? That is 360 divided by 3, which is 120. So if this is 120 degrees or more, that means that this has happened during the special offer. This is about 115 degrees. So we're going to say that no, it hasn't happened. Desserts and starters are represented by 115 degrees in the pie chart, not 120 degrees. The table shows the number of climbers that visited the climbing center on Monday to Friday 1 week. Show this information on a suitable diagram. Use the grid below. The table shows the number of climbers that visited the climbing center on Monday to Friday 1 week. Show this information on a suitable diagram. Use the grid below. Again, as we're showing the number of climbers over time, we can draw a bar chart or a line graph. So any of the two would be suitable in this case. I'm going to show the days, Monday to Friday, horizontally. I'll go for a line graph simply because there is less to draw. So Monday, Tuesday, Wednesday, Thursday and Friday. We've got the highest number per day, that's probably on Thursday, so that goes up to 44. So starting from 0, we could do 10, 20, 30, 40. That would work. And that is the number of climbers. So Monday, 18 adults and 23 children. Now I said earlier I'll do line graph, but since we've got them split into adults and children, it makes sense to do bar chart. Now you could do them side by side, adults and children separately, or you could do them on top of each other, and that's what I'm going to do. So I'm going to do adults at the bottom and then children at the top. So adults, that's 18. So we're going up to 18. And children, it's 23. So I'll put 23 on top. I've got 12 already, 12, 22, another one, that is 23. Also, to double check this, 18 and the 23 gives us 41, and that's what we have. Now for Tuesday we've got 15 adults and 21 children. So going up to 15. 15 add 21 gives us 36, so I'm going to go up to 36. Wednesday, we've got 12 adults and 22 children. And 22 gives us 34. Thursday, 21 adults and 23 children. So we're going to go up to 44. And Friday, 18 adults and 20 children. So we're going to go to 38. Now it's important that we do the key here, or the legend. So I'll do adults with a pattern like this, or it could be a specific color. And children, I could do dots. Melissa works in a charity shop. People donate clothing to the shop. Some of the clothing is sold in the shop and some is sold for recycling. Melissa keeps a record of the clothing sold in the shop 1 month. Melissa says more than a quarter of the items sold were shirts. Is Melissa correct? You must show your working. In order to work this out, we need to fill the frequency column first. So we've got shirt, 5, 10, 15. Coat, 5, 6, 7. Jumper, 5, 10, 15, 20, 21, 22, 23. Dress, we've got 5, 10, 11. So shirts, we've got 15 out of the total, which is 15, add 7, add 23, add 11, and that is 56. Is that more than a quarter? What is a quarter of 56? 56 divided by 4 gives us 14. So that is greater than 14 out of 56. And we're going to say yes. So she is correct. Students leave the school at the end of year 11. The pie chart shows what students did when they left the school last year. 90 students went to school with a sixth form. How many more students went to college than started an apprenticeship? So that is 90 students here, represented by 180 degrees. So 180 degrees equals 90 students in this case. 90 is half of 180, so the number of students is half the number of degrees. So now, looking at the number of students who went to college, that is represented by 160 degrees. So that will be 80 students. We've got apprenticeships represented by 20 degrees. So that will be 10 students. Now, how many more students went to college than started an apprenticeship? We're going to do 80, take away 10, gives us 70. So 70 more students went to college than started an apprenticeship. Jack is planning a holiday to Turkey. He finds this information about average temperatures in Turkey. On the grid below, draw a suitable diagram to show this information. Again, we've got temperatures over time, so anything over time you can show using a line graph as well as a bar chart. So I'm going to stick to a line graph. So we've got the months which we're going to show horizontally from April to September. So April, May, June, July, August and September. Temperatures in degrees Celsius, and the highest is 28. So let's see how many squares do we have in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means we can represent 2 degrees with 1 square. So April goes up to 16 degrees. For May, temperatures go up to 20. June is 25. July 28. August 27. September 24. And that's the end of the questions.